Tychonoff's theorem. The product of any non-empty collection of compact spaces is compact. Even infinitely many, even uncountably many compact spaces, their product is still compact. This is one of the deepest results in topology. 4 key terms. A net is a generalization of a sequence, a directed family of points in a space. A cluster point of a net is a point that the net visits infinitely often in every neighborhood. A space is compact if and only if every net in it has a cluster point. The product topology is the coarsest topology, making every projection map continuous. Proof. Take any net, call it x lambda, in the product space, the product of all x alpha. We need to find a cluster point of this net inside the product. To do that, we project the net onto each coordinate space separately. For each coordinate alpha, apply the projection map pi alpha to the net x lambda. This gives a net pi alpha of x lambda inside x alpha. Since x alpha is compact, every net in x alpha has a cluster point. So there exists a point x alpha in x alpha that is a cluster point of the projected net. We do this for every coordinate alpha. By the axiom of choice, we can simultaneously pick one cluster point x alpha for each alpha. Now form the point x star, the point in the product whose alpha th coordinate is x alpha for every alpha. We claim x star is a cluster point of the original net x lambda. Every basic open neighborhood of x star in the product topology is determined by finitely many coordinates. For each of those finitely many coordinates, x alpha is a cluster point of the projected net, so the net visits that coordinate's neighborhood infinitely often. Therefore the net x lambda visits every basic open neighborhood of x star infinitely often. Therefore x star is a cluster point of the net x lambda in the product. Since every net in the product has a cluster point, the product is compact. Tychonoff's theorem is proved.